I know it's been a while since many of us have been to a stadium, but who here knows which Major League Baseball team calls this stadium home? And if you guessed the Cincinnati Reds, you would be correct. You might be wondering what a baseball stadium has to do with the Internet of Things. And we didn't think they were related at first either, to be honest. But today I'll share how we went from building a smartphone, screen-free smartphone for kids, and then ended up creating a voice-first IoT platform for businesses. So when we started the product that we would call Relay, we actually were building a wireless service called Republic Wireless, where we did hybrid Wi-Fi and cellular calling. And we had a bunch of our customers that were parents, and they had younger kids. They were thinking about getting them their first smartphone, but they were really nervous about handing a 7 or 8-year-old a screen. And so the first market we launched the Relay product into was to serve these parents and their kids. We created this device called Relay. It was available in a lot of fun colors, like the teal one you see here. And it allowed parents to see when their kids got to school on the school bus, or where they were in the neighborhood when they were out playing after school. And parents loved it, right? They really enjoyed having that connectivity without feeling like they were giving kids access to things that they don't want them to access. But fairly soon after we launched, we started seeing people purchasing relays in large quantities of 10 or 20 at a time. And we were intrigued, like what could be motivating people to buy these devices in such large quantities? Well, it turned out that they weren't just big families. They were actually companies that had struggled for years on how to better connect their staff to each other and to the information that they need. And one of these customers was at the Cincinnati Reds Stadium. And many of you have probably gotten food and drinks from a concession stand like you see here. But did you ever wonder how they get the food and drinks to all the concession stands in time for tens of thousands of fans? Well, if you're like me, then probably not. I'm usually just trying to get through the line as quickly as possible so I can get back to the game. But it turns out that there's this massive behind-the-scenes, just-in-time fulfillment process that has to happen in a very short window of time. And today, quite honestly, a lot of that happens manually. It's someone in the concession stand themselves picking up this white phone, calling down to the warehouse that actually has all of the food and drink, and communicating when they're running low on stock. And then from there, it's translated into an inventory system. There's a printout. There's a lot of manual stuff that happens. And on the other side, it's sort of your request disappears into this black hole, and you have no idea whether the person has got your stuff and they're on their way, how close they are. And so what these folks were doing at the stadium was they were turning this sort of old school synchronous single-threaded process into an asynchronous trackable process, right? Orders would come using push-to-talk from a relay device that was assigned to a concession stand. They would enter a queue. They would get associated with a team member that would then carry a relay that was trackable with GPS. And you would know where your goods were, so that you weren't worried about running out of chili before the next customer came to your stand. So you think of it as really like a voice-driven, miniaturized FedEx operation inside of the bowels of the stadium. And what we realized in talking to a lot of these customers is that this wasn't a unique thing. These types of real-time critical operation functions, time-sensitive functions, they happen around the world with a ton of people. So 80% of workers around the globe actually interact or use a radio system or real-time voice system with phone calls to do their work on a day-to-day basis. And that's something that over the last 4 decades really hasn't changed a whole lot. There have been attempts over the years to change, to move to more modern technology, whether that's smart assistants or whether that's cell phones. But for a variety of reasons, that hasn't been effective. So in one sense, one very real sense, the challenge has been distraction. When you have somebody driving a truck or talking directly to customers face to face, you don't want them looking at a screen. You want them focused on what they're doing. And in addition to that, really, one of the other challenges that exists, especially for us as developers, is the challenges that come with that mobile app ecosystem. Whether it's not knowing when you hit submit on the Play Store when that app is actually going to be in front of your customers, or it's dealing with going to a WWDC and realizing that your favorite feature, favorite function is now being deprecated, and you've got to figure out some way to fix that in your app. Or it's that you're running into trouble with payments in your app, like Epic did with Apple. There are just a lot of inherent challenges that come with building for a modern mobile app ecosystem. So what is who are we, and why should you care? I'm Ibrahim Khalifa, and I'm the director of product here at Relay, and I'm joined by my colleague Brandon.
Hey, I'm Brandon Smith. I'm a senior software architect here at Relay, and I'll be back in the second half of today's presentation to do a code demo.
And between the two of us, we've got like a decade and a half of experience building hardware and software for communications and wireless technologies. And so we're really excited to share with you a glimpse into kind of what we've built and why you might find it interesting. So what is Relay? Relay is this mobile platform that has all of the guts of a modern smartphone crammed into a small, portable cellular device. And it includes a variety of sensors, and it's accessible through sort of the same familiar web technologies that you would use to build a modern web application. It includes things like GPS, Bluetooth and Wi-Fi based indoor and outdoor location tracking. It's got a global super SIM in it, the Twilio super SIM, that's loaded on via a eSIM, so it's updatable, changeable over the air. And it's also got these things that we call workflows that allow you to build applications for your users to interact real time with the hardware. And Brandon will talk a little bit more about that later. And who's using Relay? Well, it turns out, like I was mentioning, there's a lot of other industries that have this nature of problems. So today we see Relay being used not just in food services, but also in amusement parks, in hotels and golf courses, by workers to do their work more efficiently, more effectively than they could using just a walkie-talkie. And this is one of my favorite slides. It really shows you all the cool tech that we've packed into the device. Everything from the silicone overmold that makes it super durable. You can drop it on a concrete floor and not worry about it breaking, to the 3D printed antenna that we created to really maximize the antenna design and space so you can get good reception, to things like the eSIM and the NFC tag and reader that we have in the device that lets you do things like being able to track work and track when somebody takes an action on the device. And then we realized that we've built this product. It's getting used by a bunch of people in these different industries, but really what they and others want is to be able to build their own custom applications into this ecosystem. So we exposed out what we were using internally as a public API, an open API, that developers like you can use to build applications into these organizations. And the other piece that we really thought was important here was to remove some of that friction that comes with a traditional ecosystem. So today you can go in there, create your workflow, register it, and instantly deploy it to all the devices that you administrate. And then finally, really, we tried to make it as open as possible. So we've got a bunch of built-in functions that allow you to do speech-to-text, text-to-speech, using our own libraries, but you can also wire in your external third-party libraries for domain-specific language processing. So you actually get the raw audio and you can manipulate that however you need. So really powerful platform. Why don't we see this in action? We're going to show you a video with a relay that has some alerts coming into it from an IoT temperature sensor, and then responding to those alerts and resolving by tapping an NFC tag. And then we'll have Brandon come in and share all the magic that's happening behind the scenes to make this work.
Normal freezer temperatures are around 0 degrees Fahrenheit or minus 18 degrees Celsius. Restaurants store spoilable inventory in their freezers. So if something, like leaving a door open, causes the temperature to rise dangerously, they want their staff to know immediately. Here, a staff member receives a repeating relay alert.
Your main freezer has exceeded safe temperature range. Tap to acknowledge.
The worker acknowledges the alert and heads over to the freezer to remedy. After responding to the alert, confirmation that it's dealt with is as simple as tapping an NFC tag and speaking the resolution reason.
Main freezer temperature alert resolved. Push and hold the top button to record a resolution reason.
Somebody left the door open.
So you just saw an in-field demonstration of sending proactive alert notifications to relays based on a threshold triggered by the reported temperature of an IoT sensor. The integration was accomplished through the Relay Platform SDK. For nearly a decade now, starting with our work at Republic Wireless, our team has gained a deep knowledge of mobile software development. We've shipped customized Android ROMs. We've worked with Moto, Samsung, LG, and Google in standardizing Wi-Fi calling. We've developed several end-user applications, communications applications for iOS and Android delivered through the app and Play stores. And as a result, we know a lot of the ins and outs and the pain, all the facets of mobile software development. So when we started the initial development of Relay several years ago, we looked at what we learned and developed a flexible architecture that would shorten the time it took to develop new features and user experiences and get them into production. And at a high level, the relay devices, the relay devices have a persistent connection to the relay servers, the relay platform. And this connection provides real-time voice communications, as well as other control plane messages as well. So in a very real sense, the relay device is like a dumb terminal driven by commands streamed over this persistent connection from the relay platform. When we started to get feedback from certain businesses, our customers, that they wanted more control over the experience and to integrate with their own business processes, we decided to extend this architecture to them. So we built on that architecture to enable developers like yourselves to write code against our platform. Communication between the relay platform and your code is achieved through a WebSocket connection and a series of events sent to your server, with your server responding with actions. Events tell your code what has happened on the device or in the platform so that your code can make decisions by sending actions back to the server on what to do next on the device. And with these building blocks, we've enabled developers to provide customized workflows that scale from everything from Hello World to very complex integrations and to new and novel applications. Now, some of the events that can be sent to your server are lifecycle events like start and stop and errors, button taps, notification lifecycle events like when somebody acknowledges a notification. We even have timer and calendar events that can be triggered on a schedule. These are just to name a few. These and other events trigger your code to respond, and your code responds back with next actions that should be taken. And this allows you to craft a user experience wholly tailored to your business needs. So what are these actions? The available actions are too many to number here, but I've displayed a few of the more popular ones that we see get used a lot. Some were used, in fact, in the freezer temperature demo that you saw just a few moments ago. For instance, text can be spoken out on the device via text-to-speech through the say action. The listen action allows your code to listen for spoken user input via speech to text. You can even flash the LEDs in a variety of different patterns or control each LED individually. For instance, a recent to-do list integration used the LEDs to indicate how many assigned to-dos remain for the relay user. For instance, if they had 6 to-dos left, there were 6 LEDs lit up. Further, there's a rich set of alerting notifications that can be sent to one or more of your devices. And to make programming against these events and sending actions easier, we provide an SDK. The subset of actions shown on the previous screen look like this in the Relay Platform SDK for Node. The SDK is currently available as Node and Python libraries. However, because the wire protocol between the Relay platform and your servers is just serialized JSON over a WebSocket, SDKs in other languages will come. So what does this look like exactly for the developer? Well, we've strived to stay as close to a web development programming model as possible. We feel developers want flexibility and control. So anywhere you can open up a WebSocket port, you can host code written against the Relay Platform SDK. Now, to be clear, you're not uploading code to our servers. You're configuring the Relay platform with configuration metadata to connect to your servers, a lot like a webhook. And you then specify which of your Relay devices can trigger specific workflows. So in short, you start a server that is coded against the SDK. You then create a workflow in the Relay platform with connection details, and then you install the workflow on a specific device. So let's take a look at extending the freezer demo that we saw a few moments ago. Now, in that demo, a workflow sent a proactive alert notification to relays triggered by a temperature threshold of the freezer. We're going to stay in the freezer temperature domain, but instead we're going to create a query interface through a simple workflow that will report back temperature status. First, we're going to start by coding up a Hello World application. We'll deploy that, we'll test it, and then we're going to iterate over a few changes in the code to get to the query interface. So let's see that demo. So here we have a skeleton TypeScript project. And to get started, you need to install the Relay Platform SDK through npm, as we show here. Next, back into the code, you need to initialize the Relay SDK. Now, by default, this will open up a WebSocket server port on port 8080. And here we're going to create a workflow and register it with the SDK. And the key event that you need to handle in your workflow is the start event. And in response to the start event, we're simply going to use the Relay SDK to respond with the say command, hello world. And then we're going to terminate the workflow. Now we need to get this server started. So we're going to start that with npm run dev. And we need to get this on an internet accessible port. Now I like to use ngrok. During development, ngrok is useful to be able to tunnel a local HTTP port to the internet. If you want to develop on a dedicated server or a service like Heroku, that's up to you. Okay, so now that we've got the server started and an internet accessible port through ngrok, we need to tell the Relay platform about your server. And we can do that through the Relay CLI. And there's several options to get the CLI. For instance, we have Mac OS and Windows installers, but you can also get it through npm. So we're going to do that here today. So we're going to npm install the Relay Pro CLI. And once you do that, you will have the relay command in your shell. Now you need credentials to connect the CLI to your Relay platform account. I'm already logged in here. but we're going to look at some of the commands that are available in the CLI. It allows the developer like yourself to interact with the Relay platform in a variety of ways. For instance, Relay devices. Relay devices will list all of the devices on your account. These are unique identifiers that identify your related devices. And like any good CLI, you can always get help with -- help. Now, the workflow command. The workflow command is the primary use case for the CLI right now. You can create, delete, and edit workflows. We're going to show the create command help. You can see here that there are different triggers that will start a workflow. For instance, battery thresholds, button taps. We even have events emitted from the relay device, sensor events like NFC taps or BLE scans. You can even set a fairly complex schedule with a timer trigger, almost like a cron job. But a very frequently used trigger is a spoken phrase or keyword by the user. And this behaves like a simple assistant with a lot like Alexa or Siri or the Google Assistant. And we're going to use the phrase trigger today in the demo. So I'm going to go ahead and paste in here a create phrase command. We need to name the query or the workflow query. We need to provide the server port that our code is running on, and we need to use a trigger phrase of hello world. And so with that, the Relay platform is configured to trigger our code when the phrase hello world is spoken. So we're going to go ahead and switch over to a real Relay device and test it out.
Hello world.
Hello world.
Okay, so we went from 0 to hello world in just a few minutes and a few lines of code. A full-featured communications device designed to connect humans to the Internet of Things. The programming model is familiar, following a web development model. There's no app stores, no review process, just hardware and your hosted code. You know, hello world, although useful, isn't that compelling. We can do a bit better. So let's assume that we have a data API that fetches the freezer status. In this case, we are going to mock the IoT temperature sensor API. The API does exist for the sensor that we used in the previous demo, but just for development purposes, we're going to mock the data so we can quickly change data and temperature status without, waiting for the real freezers to change. So with this mocked data, let's craft a query interface that accesses the data. We need to expose functions that allow us to query which freezers are out of range defined by upper and lower limits, and we're going to expose two functions. Fetch out of range freezers, and another function that allows us to query a device's specific status. Now, there's nothing special in this demo about these APIs. This could be data from your database, or it could be another HTTP API as it is in this case. Now, hello world doesn't make sense anymore. We need to change the trigger phrase to freezer status because now we're dealing with temperature of the freezer. So we've got it changed, and back in code, instead of saying hello world, we're going to fetch the data from fetch out of range freezers, and this data is an array. So what we're going to do is simply use the relay say command to report the length of the array as the number of freezers currently out of temperature range. So let's go ahead and give that a test.
Number of out-of-range freezers is 1.
All right, let's change the mock data to report 2 instead.
Freezer status.
Number of out-of-range freezers is 2.
All right, and finally, change the data to report 0.
Freezer status.
Number of out-of-range freezers is 0.
Okay, good. Let's evolve the user experience by conditionally reporting status. If there are no out-of-range freezers, we'll report that. Otherwise, let's just report the number as we did in the previous iteration. So we'll go ahead and get that going, and let's test this code.
Freezer status.
All All freezers are operating normally.
Cool. Let's change the mock
Freezer
data.
status.
2 freezers are operating abnormally.
Excellent. That tested well. Let's go ahead and loop over the array this time and report every out-of-range freezer. All right, cool. Let's test this.
Freezer status.
Main is operating at an abnormal 21.0 degrees Fahrenheit. Ice cream is operating at an abnormal 25.1 degrees Fahrenheit.
Good. We'll change the data now to report no out-of-range freezers.
Freezer status.
All freezers are operating normally.
Okay, that works. Now, we could stop here, but let's add one more thing. First, what we're going to do is we're going to extract the existing logic into a query all function. In addition to handling the trigger phrase freezer status, as we've demonstrated, let's allow the user to provide additional input in the form of a named freezer. For instance, the user could say freezer status ice cream to get the exact temperature of the freezer named ice cream. And we can do this by using the SDK's getQueryText function. Now, this function returns a string of anything spoken after the trigger phrase. So we're going to use the returned value of getQueryText to see if we have user input. And if we do, we're going to call a new function called getQueryFreezer. And if there is no user input, we're going to call the existing logic queryAll. Now we need to implement QueryFreezer. So let's do that quickly. If you remember our data API, we have a function that allows us to get the current status of a freezer by name. And so we're going to get that freezer, and the temperature hangs off that freezer, and we're going to report that using the say command.
Freezer status ice cream.
Ice cream is operating at 25.1 degrees Fahrenheit.
Awesome. Okay, we're done.
Sweet. Thanks, Brandon. So that basically was, in just a few minutes, you creating your own custom smart assistant with its own dictionary and keywords. That's so cool.
Yeah. Today's demos, I think, show how easy it is to connect the Relay devices to your code and develop completely customizable user experiences. It really is that easy.
And this is just the tip of the iceberg. There's a ton of other sensor access, other information that you can pass back and forth between the Relay devices using these same mechanisms. And we're really excited to introduce this platform to you today, and quite frankly, excited to see what you build on top of the Relay platform. If you want to learn more information about how you interact with the platform, what capabilities are available, please check us out at relaypro.com/API. And there you'll see more rich information around what the capabilities are.